Good morning. I am Luis Alfonso Daniels, and today I will be giving you a problem which is involved in atomic spectroscopy. So, let us move on. So, the problem given: why is the ICP rarely used for atomic absorption measurements? Before we tackle the problem, um, we will first tackle what an ICP really is. ICP stands for inductively coupled plasmas. ICP is a type of plasma source in which a plasma energy is given out from electric currents through the method of electromagnetic induction. This type of plasma source produces excited ions and atoms. ICP is used for atomic determination of trace elements in various liquid samples. ICP is commercially available from several instrument companies for use in optical emission and mass spectroscopy. Out of the three types of plasma source, the ICP offers the greatest advantage in terms of sensitivity and interference resistance. Since there are actually three types of ICP, but I will not be mentioning the other two types as I will only be focusing on the ICP itself. So this is an example of an ICP, inductively coupled plasma. Then for a detailed diagram, and here is the schematic diagram for an ICP source. So these are the parts. So below the ICP is a sample aerosol inlet. Then near the aerosol inlet, this is where the argon plasma gas inlet lies. Then the same for the tangential argon flow. So as the sample goes up, the coolant tube will reduce the temperature in order to prevent it from overheating. So there's also a plasma tube and a capillary injection tube. Then uh, the RF induction coil will then turn the sample uh, into the plasma itself. So the RF induction coil is responsible for the electromagnetic induction. So after the conversion of the liquid sample into plasma, then this is where the plasma will then be emissioned. So this is the emission zone. So the ICP gives out a plasma energy of ranging about 6,000 to 10,000 Kelvin, which is pretty high if we're going to observe. So how does an ICP apply in the how I mean what is its use? How is it used? So this is an example of the instrumentation of the ICP. So first, the sample solution is then connected to a nebulizer. So the sample solution is then nebulized along with the argon supply. As you can see, the argon supply has two separate tubes, one for the nebulizer and one for the coolant. So this is where the tangential argon flow lies, if you remember. Then moving on, the nebulized sample solution then goes into the mechanism itself. Then uh, there is a coolant argon, so that yes, of course, so that it will then be reduced. The temperature will then be reduced in order to avoid overheating. Then the RF generator will be there so that electromagnetic induction will occur in order for the sample solution to turn into plasma. And then the plasma is then emission. The emission plasma will then be transferred to the monochromator. The monochromator will understand the wavelength, or I mean, not the wavelength, I mean the the uh, the emission plasma. The monochromator will send data through the detector. Then the detector will process all the information, um, information from the ICP instrumentation, until the detector will then be transfer the data through the computer, which will then be understandable by the people who will want to understand and analyze the emission plasma. So now that we already had a background knowledge for the ICP, so this is the answer. Why is the ICP rarely used for atomic absorption measurements? Because it is very expensive due to the advantages it gives. Since I already told you before that out of the three types of plasma source, the ICP gives out the most advantage out of the three. So since it has the most advantage, it is rather expensive. Since I told you that it ranges from 6,000 to 10,000 Kelvin, uh, the plasma's high temperature reduces the population of atoms in the ground state substantially. The high temperature can sometimes give a negative impact on the atoms, because the atoms can destabilize or become unstable. So therefore, it can reduce the population. Then lastly, since um, out of the three types of plasma source, the ICP gives out the shortest path length claims. So a short optical path can mean that smaller absorbance will be present. This will then lead to lower sensitivities compared to longer path length claims. So lower sensitivities can mean can bring a negative impact. So now that I have answered the question, you may research more if there are more vague concepts to you. Uh, so yeah, that is all. Yeah, this is the reference. And thank you for listening. And once again, this is Luis Alfonso Danyes. And good morning.